1 or 2 more minutes. Sabine, who's the second speaker, is coming from a class, so we'll wait maybe see if she comes, otherwise we'll start. In the meantime, if you look at the schedule, it's freestyle networking right now. Some of that. Is anyone not from science here? Not to embarrass Courtney, but Courtney is one of my former high school students. So she's part of the Waltham public.
A few years back.
And anyone want to share why they're interested in climate science?
I want to live.
Oh, good. All right, so maybe I'll just start with the introduction. So, we've got 2 objectives here on this sheet. The first is just basic information collection. The goal is that after you guys experience these presentations, you leave with some new idea, maybe some new knowledge, something interesting. But just as an observation or a slight critique, a lot of Brandeis seminars and lectures are just information collection. And when I came to a university, I was like, I don't just want to become a storage bin of facts. I want to develop the muscles and ability to have collaborative brainstorming, to have passionate discussion with different people, and then develop these new ideas. And so in my opinion, I feel that there should be a series of lectures that are more focused towards the discussion and the brainstorming than just a knowledge acquisition. Because I feel like we're all experts in getting information, but when it comes to actually collaborating and making a difference, maybe there's still room for us to do that. So the second objective is have epic discussions and brainstorming. And today, after these sessions, these lectures, at the tail end of it, 5:50 to 6 o'clock, we have a small brainstorming session where we sort of discuss how each of us as academics can make and address climate change. Because I should say, neither Paul nor Sabine are experts in climate science policy, but they are accomplished academics who are trying to address climate policy in their own way. So it's very useful in that sense, because I lust for action more than just words. And so that's going to be one of the main focuses around this. But the second brainstorming session, so at 6, I'll give everyone that needs to leave a chance to leave. And in the last 20 minutes, for anyone that's around, will be more of an experimental brainstorming session. All of those science policy people that have come and talked have stressed the idea that we as scientists have to reach out to the general public. But how can we do that? How can we bring science, policy, climate change, these ideas to the public? And one idea is maybe the Festival of Arts at Brandeis, because a lot of people from outside come there. So this brainstorming session, one of the focal points will be, can we brainstorm an idea that we will implement during the the Festival of Arts event that Brandeis happens. And this happens in April. And there's a little bit of money, too, that they give if we come up with a cool idea, which I'm sure that we will be able to. So we'll sort of talk about that at the end for anyone that's interested. At the end of this, or the bottom of this handout, you have some information on the Science Policy Initiative. There's a Facebook page that has all the content, and eventually we'll make a website, too. And if you're interested in other multidisciplinary collaborative stuff, we have a website. This is slightly different, but it's on neuroscience and topology, on musicology and neuroscience, all the different stuff that's out there. And finally, at the bottom are a few links that Sabine recommended that might be applicable for today. Okay, so with that, we have Paul. So we can
Okay, so first I apologize that I'm not really an expert in climate science. Neither am I really an activist. So. But at the moment, I'm one of the scientists more involved in the activism of Brandeis, small as it may be. So I'm going to give a few little nuggets from the point of view that really, in some sense, we're in a war right now. In some ways, it's a war of information where there is false information being propagated, and perhaps one of our tools as scientists, we might have some little nuggets, where we can try and demolish some of the arguments. Because there are false arguments being thrown out by organizations, who it's in their interest that nothing get done about climate change. But there's some certain, very agreed upon facts, and I'm just going to show some little nuggets just in some of the arguments I come across. So what is not debated by anyone? Carbon dioxide is essentially at record high. So these are data looking back 400,000 years. I mean, I think if you look back in the hundreds of millions, you can see it as high as today, but we don't want the climate that it was back in the Jurassic. So no one's debating that there's this kicking carbon dioxide. This is actually a couple of years out of date now. We're above 400 parts per million now. Okay. So the question is, and I think it's pretty undeniable by anyone that this uptick in carbon dioxide is human emissions. Some people say cow farts do more than humans, but that's just rubbish. You can model it or analyze it. Essentially, what's happened is, over these hundreds of thousands and going back millions of years since the Jurassic, carbon has been deposited into rocks, and all that carbon from hundreds of millions of years is being pretty rapidly released in a million times shorter time scale. That's on the order of a century. But people say, and I have this crazy guy who argues with me at the bus stop every day, who I think is probably, he's probably a Fox News viewer, but it's good to see, where arguments are coming from. So, carbon dioxide is a tiny fraction of the gas in the atmosphere. Okay, so how can 400 parts per million, 0.04%, you can do math, how can it be important? So I just thought I'd just throw up. Anyone know which of these molecules, or which one's most abundant in the atmosphere, or which one or two? Nitrogen and
oxygen.
Oxygen. Okay. Which ones are greenhouse gases are the ones I've shown up there? Methane is a very strong one, actually a lot more potent than carbon dioxide, but luckily for us, about 1,000 times less abundant again, maybe 100 times less abundant again. I believe so. Water. So what do you notice about the ones that are greenhouse gases? There's a little bit of helium, I think, or I put that for inert gases, some fraction. What is different about them? You just look at, what do you notice about this one, and that one, and that one? There's differences in these three.
Smaller.
They're a little bit smaller. There's a key thing that matters as far as it being a greenhouse gas.
They can have some vibration.
So, yeah, they can all, actually that one can't vibrate much. These two can vibrate as well, but what do you notice about them? They're the same element, okay? There's no difference. So basically when they move, when oxygen does that, there's no real movement of charge, it's still symmetrical. Carbon dioxide, it can do this kind of motion. And water can do this sort of motion. And what's happening is you've got different atoms in them. And when they move relative to each other, there's charge movement. And that means that they can absorb energy as photons, which is electromagnetic radiation. So you get absorption. Okay. So oxygen and nitrogen essentially do nothing. So it's kind of like saying, well, you've got a bottle of water, okay? It's clear. You can put a tiny fraction of ink in, and now you can't see through it. It doesn't really matter as long as there's enough ink. It doesn't matter if it's a small fraction of the water. So here it is, really, it's doing the same thing, it's absorbing light. But again, 0.04%, that's a tiny amount. How can it really be affecting the whole planet and so on? So let's think about this. These are very common in England, but I assume people here have been in greenhouses. Has anyone ever been in a greenhouse on a cold day? And what do you notice about inside?
Warm.
Warm. How thick does a glass need to be to make it warm inside? I mean, it's not really that thick. I mean, maybe quarter of a centimeter, half a centimeter. I don't know what a typical glass is. But that can make tens of degrees difference. So the amount, if you now think about the atmosphere, 0.04%, I'm a theoretical physicist, you can throw out numbers. I know Mount Everest, there's still some air at the top, 10 kilometers high, roughly. So let's say the atmosphere is 10 kilometers thick. So how much would the pure carbon dioxide make of that if it were a layer? So if we just took all the carbon dioxide in the atmosphere and just brought it down into one layer, how thick would it be? So you've got 0.04% of 10 kilometers. So the answer is, I believe, 4 meters. Okay, which is a lot. Even if you now condense that down to solid, you'd get, if you went down 1,000 times, generally gases are about 1,000 times less dense than the solids, you'd get 4 millimeters, which is roughly a pane of glass. So you can get tens of degrees. So it is reasonable, the numbers work. Not to mention that you can actually measure it. We know exactly how much is absorbed.
But doesn't a greenhouse, the mechanism is different in CO2? Isn't the mechanism reflection there?
No, I believe it's the same, because if you can look through a greenhouse, so it really is that the sunlight, very high energy, ultraviolet, goes through, which is why glass is transparent, the air is transparent, carbon dioxide is transparent. Anything like body temperature, temperature of the Earth, is much cooler. It releases radiation in the infrared, and the infrared gets absorbed by the glass or by carbon dioxide.
But in the diagrams I see, it's the infrared gets reflected from the glass, whereas the higher frequencies are transmitted by the glass.
Yeah, well okay, so whether it's absorbed in the air and stays here or reflected back, it doesn't get out. It's still the basic issue. Another thing that you can do in physics, if you do thermodynamics, you can say, well, we've got all this energy from the sun, okay? It's basically expanding out in a sphere at the rate that it's released. You can see what fraction of that sphere is the Earth's surface. We know how much energy we're getting from the sun, okay? We can then say, if there were no atmosphere on the Earth, so if that just heated up the Earth to a certain temperature, and then the Earth just then is radiating into space, what temperature would the Earth be? Anyone want to guess? Or anyone know? So this is basically saying, well, if there were no greenhouse gases at all, what temperature would the Earth's surface be?
Minus 200.
Not that cool. That would be maybe Pluto. So it would actually be about around 0 Fahrenheit, negative 15 Celsius. So it'd be way, way colder. So the average surface temperature is much warmer than that because of the greenhouse gases that are there. So we need greenhouse gases, and this is, again, this is all basic physics, which no one really in the anti-climate change group would dispute. Okay, that there are greenhouse gases. If we had 250 parts per million, 300, some of the methane, some of the water vapor, that's what's keeping us, around 5-10 Celsius rather than negative 15. Okay, so we know these gases, or whatever small amount, are doing something and doing something important. Okay? But of course, if you go from what's taking you from negative 15, say, to 5 or 10, well, now if you double the amount, you're up to 40 or 50. So you don't want that to happen. Okay, so basically the idea is there's a delicate balance between heat arriving in the Earth, heat escaping, and if you change that balance too much, you're going to have problems. So some of the other arguments, and I think it's worth noting that people who disagree with human-caused climate change, there isn't that much correlation with education. There are lots of highly educated scientists who basically think, it depends to some extent, do you believe the experts? And a lot of trained, even academics don't necessarily believe the experts. Okay, they may just think they know better. And the problem is, this is such a complex issue that a little bit of knowledge you can look at and say, well, I think this is happening. You don't go through all the tons of data that there are out there, and you can come to your own conclusions. And often more educated people are the sort of people who are kind of a little bit more self-pride or just think they know better and don't need to listen to others. So there's a little bit of that going on. So perhaps part of our job can be to reduce the numbers of such people, because they do have impact, especially the ones who have Nobel Prizes and so on. Not generally Nobel Prizes in this subject, but you can have a Nobel Prize in anything and then feel that your opinions on something else matter as though you are. So, some classic tables or data show, carbon dioxide, I don't know if you've seen this, but if you show temperature over time and carbon dioxide over time, sometimes you'll see this for the carbon dioxide, especially some older data. And it looks like the carbon dioxide is coming after the temperature. Okay? And more recent data suggests this isn't happening. But you know, you can look at people arguing, saying, look, it's not carbon dioxide causing it. The reason they go hand in hand is because increasing temperature is causing an increase in carbon dioxide, so therefore we can forget about it. Well, if this were true, this would actually be disastrous, because that would say that there's actually some positive feedback. So in science in general, positive feedback, a very bad thing. So positive feedback means a process occurs, it makes something happen, which increases the rate of that process. Okay? This is what happens with nuclear bombs. Okay? It's why you can get tipping points and so on. So you probably know, you know, a nuclear bomb, you can have a certain amount of plutonium. You know, it's giving out a bit of radiation. I mean, I wouldn't want to touch it, but it's not, I wouldn't mind being 10 feet away. You just add a little bit more, nothing much happens. Just add a little bit too much, you hit that critical mass, and now the little bit that it's giving off is generating more and more, you get a nuclear explosion. Okay? So positive feedback is generally a very bad thing in living things. That, you know, sometimes we use it inside our body, but we know carbon dioxide gives warming. That's just basic science, more than 100 years old. If that warming were producing more carbon dioxide, then then I would say that we're in a terrible state, because we're worried about reducing the carbon dioxide that's already there. If the 2 degrees temperature increase is going to make even more, we're in a worse state than we thought. But it's funny that people who make this argument are using it to say we don't need to worry. And this makes you wonder, well, they're really kind of saying, well, if we're not causing it, we can forget about it. But this is a bit bizarre. If an asteroid were coming to hit the Earth, and I know people who've worked in actually nuclear weapons places, they look at this because the one thing they think is sending out a nuclear explosion into space to stop that asteroid. But we would do something about it. We wouldn't say, oh, this asteroid's coming, well, it's not our problem, it was going to come anyway, let's all die. I mean, so in some ways the mentality is a little bit crazy, and it's because, which Sabine might mention more, but it's because there are agendas against reality, the science, and their whole agenda is, let's persuade people to do nothing, keep arguing. The more you argue, the less you're going to do, and they can keep making money, profits. So that's a problem. So this is something I particularly take umbrage at. Some of you who may know me as a theoretician, everything I do is computer modeling. I do, human system, neurons and so on. But basically they're saying it's all modeling, so there's no real experimental evidence. And in some sense there is some truth. Models are only as good as the ingredients. Okay? So if I model a neuron and don't put in some important ion channel, which is really important, and try and get my model to work things well, my model will make pretty bad predictions. Okay? Climate change work, though, has been going on for decades and decades. And which has been long enough that predictions from earlier models have been validated. The predictions are there. They'll predict ranges of sea change, ranges of the temperature change, and unfortunately those predictions have been true, and not only true, but when you've got these ranges saying, here's the record, here we are, and then in future they'll say things are going to be somewhere around there, because we don't know everything exactly. Then a few years go by, and nearly, I think every single thing I've seen, we've been right on that top edge, like in the bad direction. And these models can only explain even past data. If you look at past data without CO2, throwing everything you can at it, you'll be down there somewhere. So we know it is carbon dioxide. There are lots of things that cause changes in the temperature of the Earth's orbit, and obviously we know there are seasons from the tilt of the Earth and so on, and sun activity to some extent. All that is included. There's been enough top scientists in just about every field. I mean, they're throwing in the cow farts. They're throwing in so there are actually some negative feedback, which is a good thing. We'd love there to be a lot more negative feedback. One type of negative feedback is increased carbon dioxide. Got some warms the temperature. You get more plant growth at warm temperature. Some will say, great, the Earth will be better. The good thing about more plant growth is it will use up some of the carbon dioxide. So that's a negative feedback. If that were enough, if the planet probably got covered in trees again, then you might be okay. We might be okay. I don't know exactly how much is needed, but those sort of things are in the models. Okay, so everything we can conceive of is in the models, and if you, the only thing that accounts for the predicted, the observed rises recently is carbon dioxide, and they predicted changes which have happened. So the models are a lot better than my models of neurons, and my models do pretty well. So, and the problem with wanting real experimental evidence, well, there's a couple. One is that we have weather. It's hard to say one event is 100% due to climate change, okay? It's a little bit like playing Russian roulette, okay? But you have all these guns. Some might have 100 little compartments. Some have 6 compartments. Well, I'd rather play with a 100-compartment gun than the 6 if I had 1 bullet. And now we're saying going down to a 4-compartment gun or a 3-compartment, or just adding more bullets in. But maybe there's a chance, you know, maybe you'd have had that bullet from the 100-compartment gun anyway, but you're still living here. But you can, things will only be incontrovertible once it's too late. Okay. That for the people who like least disagree, so, who most disagree with climate change. You know, if we're going to say it's going to go up to 3 Celsius, then the sea is going to flood every major city. That's a prediction. We don't want to wait till every major city in the world is flooded before we say, oh, this prediction's right, we better do something about it. We want to stop it before. So we have, I mean, from a personal standpoint, it's been a little bit frustrating. This is where being a theorist, I mean, I was kind of a pretty inactive. I would take personal things, like I vowed not to drive a car when I was in England. I found that impossible in the US, especially with the family. But back in the late 1980s, early 1990s, so this is now, I'm dating myself, but almost 30 years ago, you know, it was, climate change was known by scientists. So scientists knew it. There was no real disagreement as far as I could see. The question was what you could do about it. And I was sort of naive, think, well, we can do our personal things, the governments will get told, then society will move away, you know, we can try and invest in solar, do these things, and it'll just happen. But it doesn't, it hasn't happened. And the arguments against it, first, there is no global warming. You get those arguments, and somehow the same people suddenly shift over time saying, well, when that's incontrovertible, there is global warming, but it's not us, nothing to do with us. Then you'll find people say, well, if it is us, it's actually good, you know, because maybe there's more crop growth. Siberia, Canada, there'll be more green areas. You know, some of the lakes will thaw. There'll be more fresh water there, so it'll be a good thing. You know, ignoring, you know, maybe wealthy people can move to those places, and ignoring, you know, whole continents, whole areas which tend to be the poor areas of the city that'll be submerged. Then people say, well, it's way off in the future. You know, even 2050 is probably not so way off for you guys. Certainly by 2100, you know, when things would really be disastrous. And just say, well, science will fix it. We just, you know, don't need to worry about changing our lifestyle or anything. There'll be solutions. Yeah, putting, you know, dust in the air, sea clouds, do something else. And then finally, the most frustrating thing is, oh, it's too late anyway, it's too bold, there's no point doing anything, we'll just harm ourselves and we can't fix it. So they'll jump through all those and never get to any point where, oh, there's a point, by the time they realize there might have been a time something could have happened, it's too late. And they never get to admitting, well, perhaps if you realize this up there, it would have been in time. And so we're somewhere along this, I don't think we're there, but you know, we're heading in that direction. The other point to mention with this, again, if you do get to this argument, you know, it's not, I don't think that it's going to be the case that human race wiped out or zero. It's not like a binary event. There are degrees. There are floods that increase in severity as we see. We have hurricanes, you know, depending on the sea level, they can flood more or less of a city. So every event, no event is binary. So everything you do, I mean, the good news is everything you do has some benefit. It might mean you won't know which one it is, but you know, one fewer streets might be flooded in a storm. So, it might be one hurricane doesn't quite, you know, hit, or it might be one wildfire is not quite so bad. So there are events that will, I guess it's not binary. It's not like you have to stop everything. Anything we do that's positive can have some benefit. And the same with policies. So, or any year that a policy occurs sooner will have some benefit. Okay. So that's the motivation. So why is there lack of action? And this is where Sabine will probably help to jump in with how there can be action. I found The Merchants of Doubt a very eye-opening movie, and it's really thanks to Sabine, who wrote the producer. No, is it the author of the book? And then a movie was made on it here. Naomi Oreskes is. So that is really just showing the people who are sowing misinformation. And unfortunately, scientists are really bad debaters. And you can pay actors to debate the scientists. The actors need know very little science, but they'll win the debate. And this is a classic game theory situation as well, because it is really a whole global thing. I mean, what I do, anything I do, the cost is directly to me. You know, in Sudbury right now, I'm quite happy we can actually pay 30% more for electricity, but they've done a deal where that would be the standard price, where it can be 100% renewable. So you can individually do that, and then you're doing a bit of good, but if everyone else did it and not you, you would gain all the benefits. In fact, you get benefit more if 99% of the people do it excluding you than if you're the only one who doesn't. So there's a sense that we need to get other people to do things as well. Hopefully, I'm not a social scientist, but there is some impact by just showing you can do certain things, realizing that, oh, that person's not suffering so much, they seem happy, well, maybe I can do it too. So there is that kind of social spread of activity. Our brains are very poor at dealing with probabilities in the extreme, and I think it's just the way our connections are made. They're somewhat all or none. So very low probability events have high impacts. We're just not good at dealing with that. We either tend to exaggerate them too much, or we dismiss depending on your tendency. So it's very hard to act rationally. That's just something. And the other thing is, I just know, like, the kind of, I don't know if it's a typical Trump voter, I just always think my wife's dad, the 71-year-old white guy, what's happening in 2100, do they care? And they're the people with a lot of power. The older generation, they may say they love their grandkids, but then they'll think, well, let's just make sure they're rich enough to buy some high land and not worry too much about other things. So there is that. They can be far away in space and time for some. So this is my last slide. What can a scientist do? I think counter misinformation, and I think your generation are probably more aware than mine, but there is information war just about everything now. If anyone's interested to put misinformation on the web, we know in the election there were Russian robots doing it. So anything you can do to counter false information anyway is valuable. You can act personally, and it's even better if people notice you and copy. I think Sabine might talk more about these things. Contact people who can implement change, whether it be we're going to meet the Board of Trustees about Brandeis divesting. You can call congressmen, senators, the people who are going to make energy policy. Because in the end, the world's only going to be improved if governments work together. And you're not on your own. So things are easier, you're more likely to do the right thing, and there are people around you with the same goals. So that's my piece.
Thank you. Any questions? Probably like 1 or 2 question time. Yeah.
Sure.
So I have a couple of thoughts. Maybe my own personal thoughts, but I feel one of the things we do sitting in America or in any other Western country is to think of to think of the face of climate change as it happens here. But that's not usually the face of the climate change in say Asia or in Africa. And I think one of the reasons why people here don't really feel it so much is because sort of consumerism is exported to a different place, and it's not. So what I mean to say is, like, from India, like big cities in India, really the air itself in recent years has become almost unbreathable, and that's not really climate change in the way that we think about it, but it's a lot of production related pollution, and usually the products will be shipped off elsewhere, and that's probably one of the reasons why people sitting, say, in the Midwest don't really think that life is bad for them. It's because they don't really see it, the bad in front of them, when it's happening somewhere else in the world. And I mean, this ability to sort of export the pollution somewhere else is also like a big hindrance. And I think many people, since they don't travel to these places in the world, don't really see that face of it.
So there's a couple of points there. So in London, there is pollution in the sense of, in London there was smog in the 50s, and when people are seeing that, like there is in a lot of Chinese cities now, then there is local pressure to do something. You can tell. The problem with carbon dioxide is you can't smell it, you can't see it. So the carbon dioxide is being produced right here as much as elsewhere. I agree, though, that some of the consequences, the poorer the area, the harder it is to move away. That when infrastructure goes down, the worse off you are. And there are countries like Bangladesh where what's the island that's almost Tuvalu, where the population has nowhere to go. Some countries are big enough and have different altitude of lands that you can go somewhere. Also, when there are fires in California, it's terrible. People lose their homes, but they've usually managed to get out. There's somewhere to go. Helicopters dropping water and someone to fight it. So when you have the resources, you can actually deal more and cope. So there's less death. So it's certainly in the poorer countries. I mean, I lived in Africa for a while, and if one bad season where there's no rain, if your only food is from what you grow on your local land, that's devastating. Here, if there's a bad crop harvest one year, well, prices go up, you import it from other places, but you don't get the direct consequences badly as you do.
Yeah, I mean, I just mean that it's like there is often a lack of understanding. In addition to, like, for any of these issues, there's often a lack of understanding of how the rest of the world looks in a developed country. Like, I mean, here in America, often that happens. But yeah, I mean, and that might play a role into any issue like this.
Definitely. Yeah. Thank you. I appreciate it. And then maybe we can move on to Sabine.
All right. Hi, everyone. I just have to. It's good. It's forcing me to speak quickly because I forgot to bring my charger, and the big computer doesn't let me log in. So I can only speak until my battery runs out.
Should I try to figure out how to connect the computer? Do you have slides?
Yeah. This should be
okay.
fine. What type of computer is it?
Actually, Julie, is this one?
Oh yeah, that's probably easy.
What type of computer is it? I have
It's
Dell.
a Dell. Yeah, if you have a Dell.
No, it's a
But I shouldn't speak for so long anyway. So I decided to call it. Yes, this is it.
the bottom corner of that square here.
This one?
Yeah.
Thank you. Local Action Global Vision. This is a picture of the Ende Gelände activists in Germany that are fighting against coal power plants. So just so you know who I am, I have absolutely no scientific knowledge whatsoever. I am a professor of German and Women's Center and Sexuality Studies here at Brandeis, and I am the director of the Center for German and European Studies. And I'm also now an affiliate faculty in environmental studies because I have been sort of the clown in the climate change conversation And I'll talk a little bit later on about why that is. I also helped, together with Paul, to co-found Faculty Against the Climate Threat, FACT, and we have a website. Thanks to Paul.
Oh, I
that's
meant to
called
show a couple of things.
BrandeisFact.org, so you can look it up. And this is really already an example of the kind of activism that we're hoping to engender in you, and have you join us. I currently also teach a course called Human/Nature, European Perspectives on Climate Change. I just was teaching it this afternoon. And I also am directing a smaller group on sustainability. So if you have any questions, my email is right there. It's my last name at Brandeis. So what I wanted to do is I wanted to talk about the role of activism in science behind Germany's leadership on climate, because that's really something I think I can contribute to this conversation. Then talk about my own story as a result of that, and then talk about climate activism at universities in the US, specifically the fossil fuel investment movement, and you. So, Germany. I don't know how many of you have ever been there or know anything about it, but it is a fairly small country that always pretends to be bigger than it is in the middle of Europe, and it is surrounded by other countries. It is about the size of Montana. It now has about 83 million inhabitants. The growth in the past few years has been thanks to migration, and that, of course, is partly related to climate change. It is also the fourth largest economy in the world. And when we talk about Germany in the context of climate change, people have high praise for Germany. And for some reason, Angela Merkel gets a lot of attention, and that's really not deserved. So I always have to push back on that, because it really didn't start with her. In fact, she has done a lot of bad stuff ever since she was elected as chancellor. It actually started with a movement, and the movement that may be counterintuitive to some of you, hi, was Atomkraft Nein Danke, which was an anti-nuclear power movement in the 1970s, partly inspired by such movements in the United States. And what happened was that this movement started in rural areas where nuclear power plants were supposed to be erected, and the farmers, that were mostly quite conservative people, said, not in my backyard. And so they actually did something very smart. This was near Freiburg, and they went to the university, and they got university students to help them understand what the scientific basis of nuclear power plants are. And the university students were really interested in this, and they actually started a think tank of sorts, and that's called the Öko-Institute, the Eco-Institute. And it evolved, of course, it took a while, but what happened was you had young science students and professors who were inspired by the protests of the farmers against this power plant, and who said, okay, we have a problem here, we need electricity, but we don't want the electricity from nuclear, and we don't want coal, so we need to find renewable alternatives. And that's what they set out to explore, and really the whole wave of technology innovation in Germany that resulted from this is as a result of that collaboration between science students, professors, and farmers. And I think it's very unique, and it also shows you that good developments happen when people open their eyes. What tends to happen probably in farms just as in universities is people sort of do their daily thing like this, right? They think of promotion, they think of what do I need to do to get to the next step, and they don't look left and right, and they don't ever consider whether what they're doing actually makes sense. I mean, so many of us produce publications that nobody ever reads, and maybe less so in the sciences, but certainly in the humanities. And so these people really didn't do that. They really went out of their comfort zone, and they had to translate their scientific knowledge into the language of the people, and that, as a result, garnered attention from politicians, for example. Local politicians at first, and eventually national politicians. And what happened in Germany is the Green Party is one of the results of this cooperation, and that eventually then became part of, as you know, a governing coalition. And in that governing coalition, the Green Party actually was able to anchor a lot of innovative policies in the late 90s. And the reason they were able to do that was in part that nobody was taking them seriously. You could never do that here now because the other side is watching very carefully. And in fact, in Germany, we see the same thing going backwards. So at the time, people were laughing at solar panels and windmills, and they were saying, that is ridiculous. You will never be able to produce these at the mass scale that we need them for the price that is affordable for the masses. And because they were not taken seriously, people also didn't really worry about them. And so there wasn't this really, really orchestrated counter movement that we have in the United States. And as a result, Germany can really be viewed as having financed the startup of the energy revolution, of the transition to renewables. And this is really something I think that inspires all of us and should especially be interesting to scientists, because young scientists, I know so many frustrated young scientists who can't really see how they're going to become professors, and you know, it's a very, very difficult slog. And I think thinking outside the box and trying to do things outside the box is really what needs to happen a lot more in our academic world. And collaboration with unusual partners needs to happen. We don't, you know, it's very unusual that Paul and I even know each other. Usually universities are so siloed that people only know the people that they are in the same department with, right? But we know each other because we've all formed a group and we talk to each other, and there's people from all the schools at Brandeis. And this is really what has generated a lot of positive stuff. Just a few things that came out of this. Of course, and you probably know this, job creation. This is now a very, very big job creator. As a consequence, the Green Party is in many state parliaments, in government coalitions at this point. They were almost going to join another national coalition, as you may have heard. But thanks to now the right wing being woken up, there's a lot of pushback. And right now, the coalition negotiations happening with Angela Merkel at this point are actually in danger of bringing us into a very bad time with respect to climate because neither party among these two big ones is interested in climate change, and they are not going to push things in the right direction. So there's a lot of frustration among the people at the moment. But this is what, you know, happens when people do the right thing. Freiburg is exactly the area that I was talking about, and they really have been spearheading this locally and then nationally, regionally, and nationally. So against all odds and against all expectations, renewables have been climbing dramatically in use. And at the same time, and there's been a lot of investment. Yes, it has not been cheap, but frankly, Germany can handle that. They've got a lot of money, and they should. You know, as I said, job creation has been very strong. And before I go to the negative stuff, what also, of course, has happened is, as a consequence of this growth, the price has dropped dramatically. And so now you and I can actually afford to put solar panels on our roof. And then when China got wind of it and started taking over, the prices kept dropping dramatically. Right now we have a huge problem in the United States because, as you may have heard, Donald Trump has from day one been intent on demolishing the clean power plan that Obama put in place, and he has, for example, promised or threatened to put tariffs on solar panels from China. As a consequence, the solar energy industry in this country is basically at standstill as a result of this election. At a moment when we have, what, $306 billion in cost of damage of climate change last year, right? That's how crazy this is. And people cannot get solar panel contracts because the solar industry doesn't know what's going to happen. They don't know how much it will cost. It is a complete disaster, and it would not have happened if more people had gone to vote. I'm not going to look at anyone, but it definitely is a disaster. Now, this disaster, unfortunately, is being copied. Yeah, we have seen in Germany. Until this happened in 2017, there was no party in parliament that had any doubt that climate change was a serious problem. Suddenly now, we have a party in parliament that says climate change is not happening. Okay? So the idea that this will always go in the right direction, as we had hoped, that people will do the right thing because they have the knowledge, that's just not true. It can also go backwards, and this is exactly what we're seeing in many places in Europe. It's happening. It's a little better in England for some reason, but not across the board. So what also needs to be said is that Germany, even though it has this wonderful leadership role, it is still the largest exporter and producer of lignite coal, which is the worst climate abuser. And so there's a strong movement against coal, and there was the opportunity to get out of coal, as you have heard after the COP in Bonn. There's a coalition of countries, UK leading it, that says we will get out of coal. Germany did not join it. I am, at this point, very skeptical that they will, which is bad, because they are exporting it. But, you know, it looks nice, and when you ask people who have been to Germany lately, or Europe in general, they say, wow, so many windmills. This is a view from my island, Langeoog, to the mainland. This is what it looks like, and I'll talk a little bit about this climate activism piece. So I'm from Germany, and I grew up on this little island called Langeoog. It's the third one in a row here, looks like a pistol. There are no cars on the island, just horses and bicycles. It's a very cozy little tourist destination. And that's what it looks like. It's very cold, though. Don't get fooled. It has nice sandy beaches, but most of the year it's cold. It's very idyllic. It's very green. The large part of the island is conservation land, and this is what a typical street looks like. There are about 10,000 tourists in the summer, so it's a very popular space. This is what the beach looks like. The projected sea level rise for that area in the North Sea under climate change conditions is 0.4 meters to 1 meter. Yeah, that sounds, again, very, very small. And you would think, you know, they may have a few flooding problems. But this sea level rise issue, of course, is always, you always have to magnify that with storms. So when a storm comes, these waves are amplified by the increase in sea level rise. And I have witnessed these beaches in a normal storm, let's say 25 years ago. All of it gets taken away in a real bad winter storm, right? So you come to the beach, and there's literally like nothing. You stand here and there's an abyss. And then they have to spend millions of dollars in the summer to pump the sand out of the bottom of the sea back up so that people can actually vacation here. That was normal. So it is very clear that with this kind of sea level rise, all these islands are looking at a very, very dangerous future. Here are the trends. Again, it doesn't look very much, 4 millimeters a year. Right? This is like the percentage that we were talking about. But in 40 centimeters in 100 years is not very little. And these islands, they are, they're just going to disappear. This is another piece to this puzzle, which is the groundwater salination, which is going to happen as a consequence of groundwater being, of seawater coming into the islands. And these islands, they have limited resources with respect to fresh water. So, and as you can see, this whole red area, the whole coast is going to have serious problems with fresh water. And water, of course, is already a very rare, around the world. So this is an extreme case of 5 meters of sea level rise, and then you are looking at submerging this whole area of northern Europe underwater, and this is, of course, a highly populated area. And this is the rich people. We're not looking at Bangladesh. So for me, personally, that was really, when I understood that, and it took years for me to understand that, like Paul, I feel I have known so much for so long and done so little. I really wanted to get involved and do something about it. And I have to tell you, the frustration and the depression that the knowledge of the crisis brings you, the best counter to that is getting involved and meeting other people who are involved and doing something about it. So this was a big demonstration organized by 350 Massachusetts. You should all know what that is. You can look it up. And this was in support of offshore wind. As you may have heard, there was a big proposal to have Cape Wind, and then, of course, the Koch brothers have a location on the Cape, and they decided to just simply bombard the proposal with lawsuits, knowing that they will lose the lawsuits. They sued, I think, 17 times. But their strategy was, we're not trying to win the lawsuits. We're just trying to basically get the others to go away. We're just exhausting our opponents. And they succeeded. The Cape Wind project is no longer being planned. So there's mounting frustration with this kind of activity. And in 2014, many of us marched through New York with 400,000 people. It was a huge success, this march, just sort of demonstrating the frustration and the large mix of people that had seen enough. And we're bringing students to demonstrations here in Boston. My electric car has been on display at the parade for I think this was Labor Day parade or so. I don't care. I go to anything where people need to hear about it. And the attention is really rising. When we started out, 350 is based on the idea that 350 parts per million is a livable planet, right? We're now at 410, I think, 408. We're way past that, and we're not going anywhere near this. In fact, last year was the first year in 3 years where emissions were rising again worldwide. So we really need to change. And initially when we started, nobody knew what this was. They were all like, isn't it 360? Ha ha ha. Now, wherever I go, people have heard of it. Like, how many of you have heard of 350 before? Yeah, it's changed. People have heard of it, which is a good thing. Tomorrow, Bill McKibben is speaking in Boston, and I'm taking 12 students to go. And we have to get to a point where this was a civil disobedience action in West Roxbury where we were fighting the West Roxbury lateral. And this is, I'm in the trenches there, and this is my colleague, Nathan Phillips from Boston University, and we were getting arrested for stopping the construction of this incredibly useless pipeline. And this was Harvard Heat Week a few years ago. We're joining many others who are protesting. Here's the Native American protest in Dakota. of course, now everyone is really, really frustrated by what's going on. But when you are looking at the discussion that Paul mentioned with respect to who's not on board with this, this is from Yale Climate Communication, and they're showing how many people are not talking about this problem, right? The purple areas are people who are basically not talking about this problem. The green areas are talking about it compared to the average, so it's more complicated. But basically you can see that one of the biggest problems in this country is that people don't talk about climate change. And we only have a very, very short time limit. This is what we have to burn, right? This is what we have left to burn if we want to keep the 2 degrees Celsius. We have abundant renewable energies available to us. Instead, we're stuck with the fossil fuels, which are finite. But we know that we have to turn around. We have the technical know-how. We know it increases efficiencies. We have to replace fossil fuels with reverse deforestation. We also have to reduce meat consumption. I know you don't like the farts, but they are actually significant. And if done right, the solution to the climate problem actually will solve many other problems as well, right? So what can you all do? Well, fly and drive less, decarbonize, electrify, insulate smaller homes, eat less meat, dress for the season, consume responsibly, buy locally, eat seasonal food, educate each other, talk about it as often as you can. Invest in alternatives, invest in renewables, and divest from fossil fuels. I don't have to repeat this, you are all smart enough to see this. Paul Hawken has written a book called Drawdown, and you can also look it up online, where he shows what are the most effective ways in which we can reduce carbon emissions. And actually, reducing food waste and plant-rich diet are number 3 and 4. That is completely free. It doesn't cost anything, because everyone always tells you it's too expensive to solve this problem. It is not. It is free. These are free choices you can make every single day. You're even saving money. Okay?
What's this educating girls? What happened to educating boys?
Well, it turns out that educating girls has actually a lot more positive effects on their environment than just educating boys. And boys are educated more than girls anyway. But they have found that educating girls reduces, for example, family size, and has many other positive effects, because for some reason mothers tend to think about their children, unless they live in California or maybe. Sorry.
So are you comparing educating girls to educating boys, or is it educating boys compared to educating girls and boys?
So this is actually educating girls. They have done some really interesting calculations where they've shown that the education of girls worldwide has a tremendous effect on the climate.
May I ask, is this an opinionated book, or it shows the statistics? Or?
It shows the statistics. It's also online. You can actually look at all of it online, and it's very scientific. I don't agree with all of it, but why should I? But it's very interesting, the approach he takes. And it's not just him. There's a whole bunch of people have helped him come up with these calculations. So last, I'm going to get to divestment. So why divestment? Paul mentioned it. We are here in this country looking at an industry that is funding counter-science, right? And they're not just using actors. They're using trained PR people. Merchants of Doubt makes that very clear. And as you know from the last 2 weeks, New York City and New York State have actually now gone to the next round, and they are suing these companies. They're not only divesting their pension funds, they're suing these companies because these companies have not only lied to us, they have been investing money into think tanks like the Heritage Fund and Cato Institute and stuff, which have systematically distributed doubt among people, so that people think, this temperature thing was really before the, whatever it is, they have been very, very good at making people think that the science is not really clear and that scientists are not in agreement, and so it's not a problem. I mean, that's the majority. Some people say God wouldn't do this to us, but of course that's crazy people. And then, you know, that what people say, well, divestment doesn't really solve the problem either. Well, it does eventually, because what these people are doing is they're preventing what needs to happen. What needs to happen is we need a price on carbon, right? A price on carbon is what would immediately move people away from carbon-intensive anything. But that's not going to happen if the politicians that we have are all absorbing money from the fossil fuel industry, and they're in their pockets, and they're going to do their bidding, which is what we're seeing right now in the administration. And, you know, fossil fuels are still receiving way more subsidies than renewables. Everyone always says, oh, we're putting so much money into renewables. Worldwide, fossil fuels are still receiving way more money. That makes no sense. And then, actually, scientists are being threatened and criminalized. So we need to remove their social license and free the politicians so that they can actually do what needs to be done. And universities have a particular responsibility because we know the science and we know what's true, and we have to also stand with the next generation of students and protect their future. And so we have to stop financing them. Right now, Brandeis is still invested in profiting from fossil fuel industry. That doesn't make any sense, right? We're taking money from the students to come here to train for their future, and we take that money and we put it into fossil fuel stocks so that they can hopefully make a profit, when that profit would clearly counter our student future. So it absolutely makes no sense. And we have to stop that. And in the latest IPCC report, which is now already 4 years old, they actually say that only if hundreds of billions, 100 billion a year is divested from fossil fuels, can we meet the Paris Agreement's goals of 2 degrees Celsius limit in warming. So that's even scientifically proven. Brandeis has signed on to the Paris Agreement in last June. If you want to know more about climate activism, I highly recommend Bill McKibben's book, Bill McKibben's article, Global Warming's Terrifying Math. That's where he makes the case for divestment. These 2 movies, the first one, Watch Disruption, was made about the climate march in New York, and the second one, Watch Disobedience, is about the current fights that are happening and why and how they're being organized, and it's quite enlightening. And basically, here at Brandeis, we've gone through 5 years now. From a student petition, a faculty petition, we had a committee studying the issue for 2 years. We had a report issued from that committee. We had a series of panel discussions on the issue. We had a meeting with trustees. We had a screening of Merchants of Doubt. And now last fall, we had another resolution from the faculty that also overwhelmingly voted in support of removing our money from fossil fuels. And so now we will, oh yeah, and these were the talks, you don't need to see all these details. And now we just need to, we're meeting with the trustees at the end of this month to convince them that they need to follow through on this. So I'm hoping, and this is something that, you know, Brandeis prides itself of divesting from South Africa. That took 12 years. That wasn't like, oh yeah, it's a bad idea to be invested in South Africa. It took 12 years of student activism to get the university to understand and take action. These are all divest organizations at the other universities, and they are experiencing the same kind of frustration. You know, the board of trustees saying, no, this is safe income, we need to stay invested. You know, we're not political, we shouldn't be doing political things. And so they really need you all, and they need you all to speak up to other people and to the higher ups. going to stop here because I think we're out of time. So, questions?
Thanks.
Yeah.
You said there's a big meeting coming up. When you want us to speak up, is there a specific thing we can do to be constructive for helping that negotiation? Maybe use a person to email or...
Well, the graduate students have been sort of silent on this issue, I think. The undergrads are organizing a little bit, but they're also not as organized as we would like them to be. I think having some conversations with leaders in the Graduate Student Association, there's a faculty representative, there's a graduate student representative to the Board of Trustees, making sure that they actually think climate change is a problem. And that they talk about it, because the representatives go to this meeting for 2 days. They have lunch and dinner with these people. They can talk. We just come in for 45 minutes to give a presentation. So any conversations that you can have with faculty, with students, with fellow students, and ask them, do you know what climate change is? Do you know? I mean, you will be surprised how few people actually talk and think about this. It's not on people's priority list. And
So you
that needs
recommend
to change.
contacting the graduate student representatives?
Yes, that's what I would start with, and see what they know, and if they don't know anything, send them to me, and, you know, just give them an earful. Organize, you know.
Also, like the Graduate Student Senate is always often taking in senators, so, you know, technically any of us can join. I used to be when I was a grad student, and so I think that's a great idea. And I can get the contact information of the Board of Trustees person. And we can...
I mean, you'd be surprised how much a voice matters, how much saying something, writing an op-ed in the paper. As a science person, you are taken more seriously than I am as a humanities person. I'm like, oh, this crazy German woman. But if you're saying you know science, then, oh, people pay more attention.
I have a question. So I heard that the United States is withdrawing the
From
Paris
Paris.
Agreement. I heard that Canada is also planning. I don't know, is planning or is already withdrawing the application. Do you know?
Canada?
Yeah, I heard it.
I don't
heard it
know.
in article. I don't know.
I don't think Canada is in danger
So,
right now.
yeah.
They were. They withdrew from the Kyoto Protocol. Maybe that's what you heard.
Yeah. So
Yeah.
do you know the idea why they were withdrawing the application? Because they depend very much on the fossil fuels or the United States.
Oh, why the United States?
Yeah. What would be the main reason behind?
Because of what I said, because Donald Trump and his ilk are completely fossil fueled. I mean, his Secretary of State is a former Exxon CEO, right? I mean, the people, he put someone in charge of the Environmental Protection Agency who has sued the Environmental Protection Agency for years for regulating stuff. Like, we have a crazy government, and I am not trying to hype this. This is absolutely nuts when you look at the Thomas Fire in California and the hurricanes in Puerto Rico and in Texas, and you see what's happening here in New England with this crazy weather where we have 12 and 12 up and down, and then suddenly this weird fog, and we always have snowstorms at this year where we don't have a big melt in the middle of January, right? Robins in the garden. This is completely nuts, and this is just an inkling, a small glimpse into the future we're looking at. Plants will not be adaptable to these kinds of extremes, and we didn't even talk about sudden tipping points or sudden shifts, but right now this is going gradually. It could very well go very rapidly from one day to another if certain conditions change. And as scientists, you know this better than I do. And the fact that we have a government that says it's not happening, it's absolutely mind-boggling.
So or maybe just the people that have to go, because we are a little bit over time. So anyone that wants to stay, we'll continue questions, and then we'll do a little bit of brainstorming for anyone that's interested in organizing some sort of event for the Festival of Arts where we have access to the general public from Waltham that comes. But yeah, anyone that has to leave, totally feel free. Maybe we can just give a final clap.